Today, we're diving into something absolutely amazing. One of the most beloved pop culture fantasies out there, super speed. I mean, we all know the dream, right? Dodging bullets, teleporting across the universe in a flash, or maybe just instantly zipping over to Italy to touch a plate of authentic, steaming spaghetti and popping right back. It sounds incredibly cool. But, well, today we're going to scientifically dismantle this whole idealized version of gotta go fast. We're going to look really closely at the actual realistic consequences of moving at those insane velocities.
Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
Okay, let's dive into this. What would actually happen to your squishy, completely normal human body if you suddenly possessed the ability to run near the speed of light, but you didn't have any of those convenient secondary superpowers to protect you? We're going to map out the chronological disaster of trying to be a speedster in the real world. Because, as it turns out, without an entire suite of protective physics wrapped around you, this power wouldn't be dope at all. It would be an utter disaster.
So the really crucial thing to understand right off the bat is that speed itself isn't actually the enemy here. Humans are already pretty darn good at traveling at incredible velocities without any issues whatsoever. Take the astronauts aboard the International Space Station, for example. They're orbiting the Earth at a blistering 7 kilometers per second. They're moving so fast that they safely witness 15 to 16 sunrises every single day. The human body handles absolute velocity just fine. The real, literal killer when it comes to comic book-style superspeed is actually super acceleration, basically how rapidly that velocity changes over time. To really understand why acceleration is so deadly, we've got to talk about g-force. This is the standard measurement for acceleration, and it references how quickly objects fall toward the center of the Earth because of our planet's mass and radius. In free fall, an object gains 9.81 meters per second to its velocity for every single second it falls. That right there is 1 g. Now, humans can handle a decent amount of g's, but things get super dangerous when you start pulling around 100 g's. To put that math into perspective for you, pulling 100 g's is the equivalent of going from highway driving speeds to a completely dead stop in just a single foot of distance.
Now, I want you to hold on to that 100 G danger threshold in your mind, because to get up to just a basic jogging pace for a pop culture speedster, let's say 1/10 the speed of light, and if you wanted to do it in the blink of an eye, maybe 1/10 of a second, you would experience a staggering 30 million Gs. Yeah, you heard that right. You'd be pulling 30,000 Gs just to get your foot off the starting block.
When you multiply that massive g-force by the average mass of a human being, the math becomes just horrifying. To accelerate that fast, your poor legs would have to generate over 20 billion newtons of force. Just think about that. That is 1,000 times more force than the space shuttle uses during liftoff. If you tried to instantly get up to super speed, the sheer force would instantly snap your legs like twigs. And hey, what if you tried to be a hero and grab someone to speed them out of danger? Well, the acceleration would simply rip their limbs right off, literally turning whoever you were trying to save into a fine marinara sauce.
Part 1. The speed of perception and why going fast actually means going blind. Let's move to and see how this builds, because let's say, just for the sake of argument, you somehow have incredibly durable, unsnappable legs. You still have a massive biological bottleneck right inside your head, your brain. Your physical speed doesn't matter at all if your speed of thought can't keep up with it. Human visual perception simply hasn't evolved to handle these kinds of velocities. If someone threw a plate of spaghetti past your face at the speed of a rifle bullet, which is around 1,200 meters per second, it would just be a dangerous, unregisterable blur.
Nature actually gives us a really fantastic example of this specific problem. Enter the tiger beetle, basically the speedster of the insect world. These little ferocious predators are amazingly fast, capable of covering 125 of their own body lengths in just a single second. If you were to scale that up to human size, it would be the exact equivalent of you or me sprinting down the street at 480 miles per hour.
But here is the major catch for the tiger beetle, and exactly what would happen to you. Because the poor beetle doesn't have the enhanced visual perception to match its intense physical speed, it basically becomes functionally blind when it runs. The world blurs past it so quickly that it literally has to run, completely stop to reorient its vision so it doesn't just crash into a rock, and then start running again. Without enhanced brain processing, your life as a superhero speedster would really just be a super lame series of stop-and-start microsprints. Section 2, the adiabatic heat trap, and why you absolutely cannot run through a city. Okay, let's say you somehow have the brain processing power to see perfectly while you're running. Well, you still can't use this power here on Earth, all because of a massive environmental hazard. When space debris enters our atmosphere and burns up, it's a super common misconception that friction is the main culprit, but it's actually something entirely different causing all that intense heat.
What's really fascinating here is this concept called adiabatic compression. This essentially means heating a gas by compressing it down into a smaller volume without letting any of the heat escape the system. You can actually test this at home with a regular old bicycle pump. When you rapidly pump air into a tire, the pump itself starts to get warm. You're putting energy into a newly compressed, smaller system, which in turn creates heat.
So, when you decide to run at super speed right through the middle of a city, you are acting exactly like that bicycle pump, but on a totally apocalyptic scale. You would rapidly compress a plug of atmospheric air directly in front of your body. That compressed air would instantly heat up, which of course would heat you up. First, your clothes would instantly burn and fly right off, which, let's be honest, would be highly embarrassing, and mere seconds later, you would completely vaporize yourself, burning up exactly like a meteorite hitting the atmosphere.
Section 3, fatal impacts, or as I like to call it, the bug windshield problem. Okay, so let's pretend you can run through the air without burning up into a crisp. What then? Well, we arrive at our next big physical hurdle, fatal impacts, specifically bugs. Insects are literally everywhere on Earth. Let's look at the terrifying math of what happens when you run into one of these little guys at super speed. And this brilliantly illustrates the problem. If you're running at Mach 1, so the speed of sound, and you hit a common housefly, it imparts about 58 newtons of force on you. That's roughly 13 pounds of force. I mean, it's not great, but you'll survive it. However, if you are running at 1/10 the speed of light and you hit that exact same tiny fly, the impact generates over 450 billion newtons of force.
To help you visualize that absolute insanity, 450 billion newtons is the equivalent of taking the pressure of all the millions of tons of water held back by the Hoover Dam and concentrating all of that immense, crushing power directly onto the surface area of a tiny fly's face right up against your body. Hitting just one single bug at super speed would instantly blast a hole right through you, leaving you as a very tragic piece of human Swiss cheese, and definitely not mozzarella.
Which naturally brings us to part 4, the space problem, because there is truly nowhere to run. At this point you might be thinking, you found a loophole, right? Like, what if you avoid the atmosphere and the bugs entirely? What if you use your super speed out in the vacuum of space? Surely there's nothing out there to hit or compress, right? Well, unfortunately for our aspiring speedsters, there is literally nowhere to run.
You see, space is not actually entirely empty. On average, inside every single cubic centimeter of volume in space, you're going to find a single atom. Just one atom. Now, at normal speeds, this is essentially a perfect vacuum, no big deal. But when you're traveling at relativistic speeds, approaching the speed of light, this tiny, solitary little particle suddenly becomes a deadly projectile.
According to some pretty wild calculations by physicist William Edelstein regarding the perils of light-speed travel, hitting these scattered, lonely atoms at near light speed delivers a massive, fatal dose of radiation in just a single second. It would be like sticking your head in the Large Hadron Collider, but much worse. The physics of moving that fast are just so extreme that, as comic books have actually occasionally pointed out, even trying to give your partner a quick kiss at that speed would literally cause them to explode.
Part 5, the power you actually want, which is super perception. So, practically speaking, if you tried to zip around a city acting like a hero, you'd end up a shattered, naked, burning, completely confused mess. The physical act of moving your mass that fast is just fundamentally flawed. But, hey, there is a fun plot twist here. The super speed you are actually dreaming of isn't a physical power at all, it's totally mental.
The only way pop culture speedsters actually function is by possessing super perception. Some comics even explain that speedsters can perceive events on the order of attoseconds. This kind of super perception gives you the absolutely wild ability to take a single second in real time and stretch it out into 231 billion years inside your own mind. You can notice literally everything happening down to the molecular level. You'd live life on this eternal delay, giving you infinite time to formulate the absolute perfect reply to literally any question asked of you.
So it turns out that moving fast is a physical nightmare.
but thinking incredibly fast. That is the ultimate, scientifically sound superpower. Knowing what we've uncovered today about the snapping bones, the blazing adiabatic heat, the devastating insect impacts, and the fatal space radiation, I gotta ask you, do you still want physical superspeed, or do you realize that what you really want is super perception? Think about that next time you watch a speedster zip across the big screen. Thanks so much for joining me on this explainer, and keep questioning the science behind the fantasy.
If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious and keep looking up.